In this video, we'll take a look at how to find p-values using the TI calculator. This comes from section 8.4. A p-value is the probability of getting a test statistic at least as extreme as the one representing the sample data, assuming that the null hypothesis is true. When you run a hypothesis test using the TI calculator, the p-value is automatically included in your results and you don't have to calculate it. The section 8.4 homework will ask you to find a p-value given the test statistic only. And to do that, use the normal CDF function if your test statistic is a z-score. We've done that before. And then we use the t-CDF function if your test statistic is a t-score. We haven't done that using the t-CDF. So here's a couple of examples from homework. The first one is from problem number 2 on my math lab. Use technology to find the p-value for a right-tailed test with n is equal to 15 and a test statistic t of 2.706. All right, to find the p-value on the TI calculator, you press second and then variables to access the distribution key. So second, vars, there's our distributions. Select t-CDF. On this calculator, it's option number 5. And the command is very similar to the normal, except t will only work with, very similar to the normal. You enter your lower value, your upper value of your interval that you're trying to find the area of, and the degrees of freedom, and then the calculator automatically adjusts for mean and standard deviation. You don't have to worry about that. So the lower value, since we're using this to find a p-value for a right-tailed test, that means that the right tail is shaded. So the lower part of our interval would be 2.706. The upper would be to infinity, so that's 1e99, 1 times 10 to the power of 99. That's our infinity. And then degrees of freedom is always the sample size 15 minus 1. So in this case, would be 14. Close out parentheses, and that says that the p-value, or the area from 2.706 to the right, is a 0.0085, rounded to 4 places. All right, the next example is the same thing, except now we have a two-tailed test. So use technology to find the p-value for a two-tailed test with n equal to 16 and a test statistic 3.301. So a reminder, a two-tailed test goes to the right and to the left. So we want the area to the right of 3.301 and also the area to the left of a negative 3.301, so that we have the area in the two extreme tails added together. So we use the same as last time. We find those second distributions, select t-CDF. The lower portion of our interval is 3.301. The upper bound of our interval is infinity again. And degrees of freedom for this are 15 because we have a sample size of 16. Again, degrees of freedom are 1 less than the sample. So in the right-hand tail, we have an area of 0.002, and what we have to do, since it's a two-tailed test, is multiply that value times 2, and we end up with 0.0048. So that's how you find p-values. If you don't have all the information to run the test, and you're just given the critical or the test statistic, you can use the t-CDF, which is very similar to normal CDF, to find those areas.